I knew this day would come. I just didn't realize it would come so quickly. By the time we're done here, we will understand why two models are commonly used to describe network communication. So today is the day I feel like my parents probably did when they described to me what an 8-track cassette was. Because today is the day that I described to you what a VCR is. And I hope that many of you already know what this little widget is. It's a video cassette recorder. It was one of the first things that allowed us to get our Friday night entertainment, head on down to Blockbuster Video, pick up a VHS or Betamax formatted cassette, and watch a movie for the evening. You don't know about Betamax? You haven't heard of Beta? What? It was the original format to come out for a VCR. It was actually a better format. It was higher quality than VHS, but as the tale would have it, VHS ended up winning one of the original format wars. And we see this often when a new technology like Blu-ray came out. You see two standards come out, people buy up one or the other, and at the end, one fades into the sunset and the other dominates. Well, the original format war, at least as far as I know, actually came in the network world between TCP/IP and OSI. Now, just about everybody has heard about the TCP/IP protocol. A few less have heard about the OSI model, and far less have heard about the OSI protocol. Believe it or not, both TCP/IP and OSI were competing protocols back in the day. And the way it went, at least as far as we know the story, is there was a group of universities that wanted to trade files across this thing called a network. And they developed the ARPANET and used TCP/IP to do it. And it worked. We were communicating and life was good. But at the same time as TCP/IP was being adopted and released, OSI also came out. It was the better, more scalable protocol. As a matter of fact, the government believed in it so much they enforced it. But the challenge is TCP/IP was already there. It was already in production. So even the agencies that were supposed to be listening to the government were like, yeah, we're doing OSI over there. And they were doing TCP/IP for everything else. So in the end, even though the government was behind it, even though OSI was technically the more scalable, quote unquote, better protocol, TCP/IP ended up winning. And as fate would have it, TCP/IP version 6, the version of it that we're now all slowly adopting, the new version of TCP/IP, looks very familiarly like the original OSI, at least in the way its addressing works and how they've made some of the scalability constraints of it. But that being said, you would think if TCP/IP was the one that ended up winning the war, then why do we even hear about the OSI model anymore? Well, the reason why is because OSI was not only the better protocol, it just had a better model. Meaning, TCP/IP, the model that they created to describe network communication with TCP/IP, was good, but it wasn't great. There was actually some challenges that it had where you couldn't quite describe things all the way because they really were trying to be efficient and grouped layers together, and especially this layer. I'll come back to that a little bit later in this skill when they took data link and physical and merged them into one. So TCP/IP does have a model, and yes, it exists, and yes, it's kind of useful, but in 99.999% of the networks of today, we use the OSI model to explain network communication, to describe how to properly build a network, to describe how the different components of a network work together because it's got the right number of layers, 7 layers. So in a little bit of irony, we end up using the OSI as the preferred reference model to describe how TCP/IP networks, which is the preferred protocol stack, end up working. Now you understand why two models are commonly used to describe network communication. I hope this has been informative for you, and I'd like to thank you for viewing.